So this is our lab number 3, that is about the single sideband suppressed carrier modulation and demodulation. Previously we have covered double sideband suppressed carrier modulation and demodulation. The reason we are performing the single sideband suppressed carrier, because in this we will only transmit one sideband from the sender to receiver, while another sideband will be suppressed along with the carrier. The reason to suppressing the another sideband is that both of these sideband, the upper end sideband and lower sideband, both carry the same information. That's why there is no reason to send both of the sidebands on the receiver side. That is the reason we are suppressing any one of the sideband, either lower sideband or upper sideband. In this way we will save the power of the signal. So this is the basic block diagram of single sideband suppressed carrier generation. In first block you can see this is a mixer, or we can say it as a product modulator or balance modulator. There are two input going in this block. First one is audio signal, that is also a message signal or information signal, and second one is carrier signal with a high frequency, and the output of the mixer is feeded to the band pass filter. This filter is band pass filter, and band pass filter properties will be set according to the band we want to transmit from sender to receiver. Either if I want to transmit the lower sideband, then I will set the properties of filter according to that. If I want to send the upper sideband, then I will set the filter frequencies according to that by using the capacitor and resistor values according to that. So on the output I will get either lower sideband or upper sideband. This way here we will get, let's suppose if this is a lower sideband, then I will get the low frequency signal, and let's suppose if it is a upper sideband, then I will get high frequency signal for the transmission. That means we can send either lower sideband signal or upper sideband signal, depend on us. So let's move toward. So this is the procedure for single sideband suppressed carrier modulation. First of all, we will set the parameters of message signal or audio signal. The parameters, that is amplitude and frequency. The amplitude of message signal should be 1 volt peak to peak, and frequency should be 3 kilohertz. And the carrier, after that we will set the parameters of carrier signal, that is 6 volt peak to peak amplitude, and the frequency is about 455 kilohertz. That's the same parameter as we set in double sideband suppressed carrier modulation. Now we are going to move towards the trainer to set these parameters of message signal and the carrier signal. After that, both of these input, the information signal and the carrier signal. So using this block, that is audio frequency modulation signal generator, we are going to take the audio signal from this block. I have set the properties, that is amplitude and frequency according to the procedure, that is 1 volt peak to peak amplitude and frequency is about 3 kilohertz. Okay, let's observe the output of the audio signal on oscilloscope. Okay, I have set the cursor function on time, you can see here. So using the time cursor function, I have set both of these cursor on one cycle, and I am calculating the time, that frequency. You can see here we have set the frequency approximately 3 kilohertz, that is about 2.94 kilohertz. Now I am setting the cursor on voltage to actually check the voltage. So by setting the cursor on voltage, the voltage reading is coming here, that is about 1.01 volt. That is the actually peak to peak voltage. Okay, now I am going to set the properties of carrier signal. Okay, this block is for carrier frequency, that is radio frequency carrier signal generator. From both of these knobs we will vary the frequency and the amplitude. I am setting the frequency, that is about 455 kilohertz, and amplitude about 6 volt peak to peak, and I will place the probe of oscilloscope on this point, that is TP9 point. That means I will get the output of carrier on this point. Now we are going to observe the output on the oscilloscope. So now we are going to observe the carrier signal on the oscilloscope. So this is the carrier signal. I have set the cursor function on time. So cursor function is on time, and these are the vertical cursor which shows the time, and the time or frequency reading shows here that is about 454 kilohertz. So that's almost near to 455 kilohertz. And now I am changing the cursor function from time to voltage for taking the vertical cursors. Okay. So the voltage reading of peak to peak voltage, that is about 5.90 volt, that is almost near to 6 volt. So this is the parameter which we have set for the carrier frequency. Now let's move towards the single sideband suppressed carrier modulation. So after setting the parameters of information signal and the carrier signal, we are going to take the connection from information signal block and the carrier signal block to the double balanced amplitude modulator block. So message signal will be fed as an input to the balanced modulator on this point, that is modulating input, and the carrier signal from this point, TP9 point, will be given as input to this double balanced amplitude modulator. After that, we are actually following the block diagram of single sideband suppressed carrier modulation that we have discussed in the theory section. So the output of this block, that is double balanced amplitude modulator, will be fed to the band pass filter. You can see here it is also written here, band pass filter. So after that, to observe the output of single sideband suppressed carrier modulation, we will place the oscilloscope probe on this TP7 point. So this is the output of band pass filter on this point. Okay, now I am going to turn on power and we are going towards the oscilloscope. So this is a single sideband suppressed carrier modulation output. You can see here we have got just one frequency component, either lower sideband, either upper sideband, while all other frequency components are suppressed, that is carrier signal, and either upper sideband is suppressed or lower sideband is suppressed. So that's all about the single sideband suppressed carrier modulation.